Hi, I'm Drew Moyer, and this is how to organize coordinate proofs in geometry. Coordinate proofs have been given variables for coordinates instead of numerical values, but we're still required to prove something about the graph. So here we have quadrilateral LMNO, and we're required to prove that this quadrilateral is a parallelogram. Well, I can prove something's a parallelogram if I can prove that both sets of opposite sides are parallel to each other. Let's start with the tops and bottoms, LM and ON. And if I can prove that their slopes are the same, then they must be parallel. So let's start with LM. And I want to take the second y-coordinate, which is M, minus the first y-coordinate, which is M, over the second x-coordinate, which is z plus L, and the first x-coordinate, which is L. Now let's simplify that, and I would get that LM is equal to M minus M, which is 0, over z plus L minus L, which is just z, which equals 0. So the slope of LM is 0, aka a horizontal line. Let's see what the slope of ON is. Again, we want to take the second y-coordinate, 0, and the first y-coordinate, 0, subtract them. And then I want to have the second x-coordinate, z, minus 0, which is the first x-coordinate. And now I get that ON is equal to 0 minus 0, which is 0, over z, which again is 0. So LM and ON have the same slope. Therefore, they must be parallel. So I'll go ahead and mark that on my graph. Now we want to see if OL is parallel to NM. So let's take a look. Again, I want to take the second y-coordinate, which is M, subtract the first y-coordinate, which is 0, and then I want to take the second x-coordinate, L, minus the first x-coordinate, 0, and I get that the slope of OL is equal to M over L. So let's keep that in mind and move on to our next line, which is MN. And again, we want to take the second y-coordinate M minus the first y-coordinate 0 over the second x-coordinate, which is z plus L, minus the first x-coordinate, which is z. And then we're just going to simplify. M minus 0 is M, and z plus L minus z is L. So we have all four slopes now. And as you can see, OL and MN have the same slope, which means that they must be parallel. So now I have proven both sets of opposite sides parallel to each other, and therefore quadrilateral LMNO is a parallelogram. So I'm Drew Moyer, and this is how to organize coordinate proofs in geometry.